So we've already seen how to use the method of undetermined coefficients to solve a non-homogeneous equation by finding a particular solution. I want to talk about sort of an alternative to the method of undetermined coefficients. It's just an alternative. Anything you can do with undetermined coefficients, you can do this way, and anything you can do this way, you can do with undetermined coefficients. But sometimes this is a little bit faster and maybe a little bit easier to keep in your head all at the same time. So what we're going to do is imagine that instead of having a real valued differential equation, right, that is a differential equation whose solutions are going to be functions that take in a real number and spit out a real number, we're going to imagine that they're complex valued. So they take in a real number, but then they spit out a complex number. What does that look like? Well, a complex number is just a real number plus I times another real number. So if I call my complex valued function z, it'll be z of x. So x is still a real number. The inputs are still real numbers. But then the outputs look like something plus something times I. And the real part, that's just a function of x. It takes in x and it spits out a real number. V takes in x and spits out a real number. So we're going to observe that if you have differential equation, this will be second order, but it works in general for any constant coefficient equation as long as those coefficients are real numbers. If you have a complex valued differential equation with real coefficients, then if you split this into the real part and the imaginary part, it splits nicely. So how are we going to use this? We're going to use this. We will be presented with a real valued differential equation with real coefficients, and we're going to just try to guess, is that the real part or the imaginary part of some complex valued differential equation with real valued coefficients. That's the idea. Let's see this in an example. Okay, so y double prime plus 2y prime plus y equals 50 sine 3x. That is a real differential equation, right? Everything inside is a real number. If you look at 50 times e to the 3ix, that's going to be 50 cosine 3x plus I times 50 sine 3x. So you can see that our right-hand side is the imaginary part of a function we know and love. So the complex value differential equation we're going to consider is this one. And you can see that this is really nice. It's got this sort of exponential form, and we know what to do with those. For this differential equation, the annihilator is d minus 3i, right? Which means that our particular solution should look something like a constant times e to the 3ix. This constant a naught could be a complex number, and it usually is a complex number, so we have to take that into account. All right, so what we're going to try to do is solve this complex valued equation just as we normally would. So what we're going to do is to treat this zp as a possible solution and figure out what a naught has to be. So we compute the left-hand side, and we set that equal to the right-hand side. Let's clean that up a little bit. And we can see that we need a naught to be 50 over minus 8 plus 6i. Now we want to express that in the standard form. So we multiply by the complex conjugate over the complex conjugate. That always results in the bottom in a squared plus b squared. So we end up with minus 4 minus 3i. So let's go ahead and rewrite zp. So zp will be minus 4 minus 3i times e to the 3ix. Remember, we're looking for the imaginary part of zp. So we've got an expression for zp. We just have to write it out and find out what's the imaginary part. So the imaginary part that we're looking for is minus 3 cosine 3x minus 4 sine 3x. And just to double check, let's make sure that actually works. And you can see after you do a little bit of differentiation and some arithmetic that it does. So here's our particular solution. How do you find the general solution to this equation? You solve the associated homogeneous problem, which we know how to do, and add a linear combination of those elements to this particular solution, minus 3 cosine 3x minus 4 sine 3x.